So now that we've gone through and talked about what the central limit theorem is, now we're going to apply it to some of these types of problems. And we're going to see stuff from 6.3 and then 6.5 sort of woven in here. So example 1 says the population of men in a certain country have weights that are normally distributed with mean 172 pounds and standard deviation of 19 pounds. What is X and how is it distributed? So, right, X is this distribution, right, of these men in a certain country, their weights, right? It's distributed by, so X is distributed, right? It says they're normally distributed. So normally distributed with mean, right, of 172 pounds and standard deviation of 19 pounds. So what about X bar, right? So it's the sampling distribution of sample means. And so still of the weights of these men. Now, central limit theorem states that if the initial population was normally distributed, then X bar will also be normally distributed. So X bar is also normally distributed, right? And so if we recall, the mean of the sample means is equal to the population mean, and the standard error is equal to the population mean divided by, the population standard deviation divided by the square root of n. So in this case, right, the mean would also be 172, and then the standard error, we can calculate that out really quick, would be, it'd be 19, right, divided by the square root of whatever the sample size is, right? And so we don't really know what the sample size is. So we'd say 19, right, divided by the square root of n, okay? All right, so C says, what is the probability that an individual man selected at random has a weight less than 150? So we're selecting just an individual, right, just some random person. And so this would fall back just with our stuff we saw in 6.3. This would not be the central limit theorem because we're just selecting an individual, right? Individual man. So we want to know, right, the probability that X is less than 150. So if I were to draw my curve, right, so the mean we said is 172. So 150 is somewhere here. Less than that would be shaded this way. So, right, so my normal CDF looks like the lower limit, right, is going to negative infinity, so negative 99,999. My upper limit, right, goes to 150. My mean of the population was 172, and the standard deviation was 19, okay? So in order to get to normal CDF, right, we hit seconds and VARs, go down to normal CDF, then we have the lower limit, so negative 99,999. My upper limit was 150. My mean was 172. And my standard deviation was 19. We'll paste that. And so the probability, I'll write it again, that X, right, is less than 150 would be roughly 0.1235 would be the probability there, okay? So D, right, looks very similar, but it says, what is the probability that in a sample of 40 men, the mean weight is less than 150 pounds? So it's saying the mean weight. So we know, right, sample of 40, so n would be 40 in this case. And so they're asking the probability that X bar is less than 150, okay? So C and D, again, look very similar. C is an individual person and D is the mean weight. So there is that slight difference. And so when I, again, draw this, right, so I have the 150, or I'm sorry, not the 150, the 172. So 172, right? The 150 is still somewhere down here, shaded down. So when I now use my normal CDF, we're going to use our central limit theorem. So the lower limits, the upper limits are going to be the same. The mean is going to be the same because the distribution of sample means, right? The mean of the sample means is the same, so 172. But now my standard error, right, is what my central limit theorem states that it's the population standard deviation, which was 19, divided by the sample size, which in our case is 40. Okay, so we'll hit second vars. We'll go down to the normal CDF. Most of these are going to stay the same, but for my standard deviation, we then need to divide it by the square root of 40 to get that standard error for my central limit theorem. And so in this case, right, so it says that the probability of this happening, right, that the probability that the sample mean, the mean weight is less than 150 would roughly be 0, right? This would be very, right, impossible to happen. So this is just an example of what we can do with this, sort of the difference between just like a normal population and using that central limit theorem with these, this mean weight.